What is three-phase balanced delta connection? So name itself is the three-phase. So you'll understand three-phase we used to represent with three different colors as well as the different wires also you can see. Generally will have representation in case of delta. So there we have three live wires. Okay, here we don't have neutral wires directly. So first of all, we'll try to see how this delta network that is going to look here in case of three phase. So that we'll have better understanding about this. So like this, name itself is what here? Delta. So we have to form the delta. Like you have earlier, you have seen a star, delta, delta star. So here delta we are going to form. So it has three sides. Okay. Now in this, from this point, this will call suppose A. From here, one line is taken. Again, this point we'll call as the B. Okay. From B point, another line is taken. Again, this point we'll call as the C. So from the point C, again, another line is taken here. So this one, first one, what we have connected from the point A, this is called as the line A. This is called as the line B, and last one is the line C. So now in this, if you see that how we are able to represent the voltage here. So this is the plus, this one the minus. So this is the voltage here that is related to A. Again here we have another things. This is for the uh, plus minus here. This will write as the EB. And this one last one again we have here plus minus. This one we are writing for the EC. Now in this we can represent the current also here. So this current is IC. Okay. And here current is going to be IB. And here current is going to be IA. So like this, we have internal part of this one. Outside here, we'll have current. This is the IA. This current is here, IB. And this current is here, IC. So the voltage between line A and line B will be the, we call as the line voltage between A and B. Similarly, the voltage between B and C will call line voltage BC. For our understanding purpose, we can make some connection here. So here it is very important that in case of delta connection, we don't have neutral wire. Okay. So that is the very important here. So we have three lines here. Now here if you see the relation here, how it is going to have relation between line and phase. So that line voltage is equal to phase voltage here in case of delta connection. And here again line current equal to root 3 times of the phase current. Okay. So this inside whatever current we are showing, that will be the phase current. So that will have phase separation of minus 30 degree. So it depend upon the direction. So again here IL, if you want, we can write in terms of this magnitude as well as in terms of angle. So now second part is what here? Phasor, draw the phasor diagram Okay, so now we need to draw the phasor diagram. So to represent the phasor diagram here, so we'll have proper representation like three different colors we are going to take, like we have red or blue, yellow we can take, okay, to represent the three lines. So on the basis of that here, if you see that it has three phase and total angle at around the point is what? 360 degree, okay? So now first of all, if you want means you can have three lines like here, all are separated by the 120 degree, okay? So approximately you can draw like that. So this part again here. So this one is suppose we are taking B or Y. This one we are taking as the BBR and this one is the BYB. So B is blue, R is red, okay, Y is the yellow. Now finally we have to represent the current here. So in this case, if see that this is the graph here that going to represent the current of the, that is the IR. It's make the angle here, that angle is phi. So opposite of this, okay, if we protect here dotted line, we'll have minus IR. Similarly, we can take three different colors, so it will be easy to understand for us, okay. So now we'll have before blue, okay, so that we are going to see. Now again that blue, so this all IR, IB, IY will be separated by 120 degree. So finally here we have, what is this? IB. And left back side, just dot dot, same line, okay. This value is how much? This value is minus IB. Now which one is left? Yellow, okay. So that yellow we need to draw. So another, it will be again at 120 degree. So this is the IY and backside of that same you have to project. So this will represent what? Minus IY. Okay. So like this now we have these three things and finally we are trying to find the resultant one. So suppose first we'll look between here right side IR and minus IB. So in this if you will try to find the resultant, so in case of vector you know that head of one should match with the tail, okay. So that's why here we have to project the vectors. So diagram will look like this and from this side again we have this part. So finally this will represent here IR minus IB, okay. This IB parallelly you are projecting here, okay. So finally it will become IR minus IB. Similarly here again to find the resultant one vector we have to project here, okay. So parallelly we are projecting. So here we'll get the resultant vector. So what will be the resultant vector here? IY minus IR. Similarly here again for this side between IB and minus IY. So again you have to shifting IB parallelly here and here IY. So if you draw properly it will look like a parallelogram. So finally what we have here, this is the IB minus IY. So like this we are able to represent the phasor diagram of the three-phase balanced delta connection. So here your separation between that angle is important here. So between BRY and BBR, we have angle of 120 degree. Again, between BBR and between BY, B angle is what? 120 degree. So automatic angle between BYB and BRY will be how much? 120 degree. Similarly, when you're drawing the current also, so the angle between IR and IB is how much? 120 degree. Between IB and IY, 120 degree. Again, between IY and IR is the 120 degree. So like this, we have to plot the phasor diagram, and you can show the relation between all lines with the line current and the phase current. Okay. Thank you.